Today we're going to review functions because functions are a huge part of pre-calculus and calculus. So this is an important topic to really understand with the definitions. We're going to start off with the definition of a relation as opposed to a function. So a relation is really any set of ordered pairs. There doesn't have to be a pattern to it. There doesn't have to be any kind of relationship. You're just taking some ordinates and some abscisses, or some abscisses and ordinates, and grouping them together. An example is here. This is a set of coordinate pairs, 3, 2, 3, 5, 0, 1, 6, -1. And this is an example of a relation. I don't even have to look at the x values. It doesn't matter that they repeat. Any group can work as a relation, so there's no pattern to it and there's no restrictions. Some sketches of relations would be a circle. If I have an x and y axis, a relation is anything that connects the x and y values together. So we could have a circle, that's a relation, or a standard function like a parabola. Both of those fall into the category of relations. Now functions are a certain type of relation, and their definition is much more specific. The definition of a function is the fact that every input has only one output. So inputs would be your x values and outputs would be your y values. And you need to know that all functions are relations because, again, the relation doesn't have any particular pattern. You're just tying an x with a y and grouping them together. However, not all relations are functions because we have to have the criteria that every input has only one output. And we can look at that when you're looking at examples. Basically, you look at the x values. If the x value repeats and they point to different y values, then you know the relation is not a function. Now, when we work with functions, we use what's called function notation, and this gets to be really handy when we start to look at composite functions and when you get into a little bit of calculus at the end of the year. To write a function in function notation, you're basically going to replace the y value with an f of x. So you're going to replace y with an f of x. So f of x represents the y value, whereas x obviously represents the x value. So for example, if I start with y is equal to 3x plus 2, I can write that as function notation by just representing the y as f of x. That is a function in terms of x, 3x plus 2. It doesn't change the meaning of the function, it's just a different way to represent it. As a coordinate pair, I have x and f of x. So a type of example that you're going to have to do is to look at a relation and determine, just by looking at the coordinates, whether the relation is or is not a function. To do that, all you really need to look at are the x values. So you look at the x values. I have a 1, a 3, a 5, and an 8. Since they are all different, this relation is a function. That's all you need to do. If all 4 x values, or if all the x values are different, it is automatically a function. Now look at the second one. I have a 1 that points to a 1 and a 1 that points to a 3 right here. This makes it fail. Okay, this is not a function. It is a relation, but not a function because it fails the one output for every input criteria. We can write a function when given a set of rules. So if we take a look at this, I have my rule is I'm going to subtract 5, then take the square root. So we have to think about an order of operations. If I start with my variable x and I'm subtracting 5 first, I need to put that in parentheses and then take the square root. So that is my function f of x. That represents subtracting 5 from the value and then taking the square root. We can also write the rule from the function. And again, we have to think about our order of operations. If I have this function, 3x cubed plus 8, you have to think to yourself, what am I going to do first to the variable x? And to the variable x, I'm going to cube it first, then multiply by 3, then add 8. So to write the steps, you could say cube, comma, multiply by 3, or you could also say triple, and then add 8. So that's a way of writing rules from functions or determining functions from rules. Alright, and as you probably remember, we can do a visual test of a function by looking at the vertical line test. If I pass a vertical line, it should only cross the function at any place once. So the first guy here, he is indeed a function. But if I move my line over to this guy, he fails, except for this point here. Everywhere else he crosses twice. So this guy is not a function. If I were doing a yes or no, this is yes, and this is no. Finally, we're just going to review evaluating with function notation. Basically, if you're given a function, f of x, and you want to evaluate, let's say we want to find f of, well, we'll start with the easiest one, f of 0. All you do is you take the 0, replace x with it, and evaluate your right-hand side. So f of 0, in this case, I'll spell it all out, but whenever you evaluate the function at 0, all you end up with is the constant. So f of 0 is 5, written as a coordinate point, be 0, 5. F of negative 2, we'll do that. So if I want to evaluate the same function, f of negative 2, you're evaluating the function at negative 2. It's 3 times negative 2, quantity squared, plus 5. I did a negative on purpose. You have to square the negative 2, and when you square negative 2, you get positive 4, please. Don't tell me it's negative 4 just because your calculator says so. 3 times 4 plus 5, that's 12, and you add 5 more, and you get 17. So f of negative 2 is 17. As a coordinate pair, it's negative 2, 17. And that is a quick review of functions. We will work more on this in class and practice in class.